Hello, today we're going to be talking about area and perimeter and what we've been working on in 4th grade. This week we have gone back to the standard with area and perimeter in it, and we've expanded on what we had done in quarter 1 in solving area and perimeter problems by introducing the formula for perimeter and the formula for area, and then working on solving some problems that are a little more higher level thinking. So I'm going to take you through 3 types of problems that students need to know how to solve. They can see different combinations of these problems and some more kind of big project type problems. We solved one this week about finding the biggest possible area for a dog fence with a given number of feet of fence. So the problems can be quite complicated. I'm going to kind of just show you the basic area and perimeter problems that we worked on this week. So we're going to start over here. And this side of the board, we're going to talk about when we have a rectangle or a square and we know the measurement of one of the dimensions, and then we either know the area or the perimeter. How can we find the missing dimension using what we know? Use the information you have. All right, let's take a look right here. So when I look at this, I can see that the length is 10 inches. I do not know my width, so this would be my width right there. That's the unknown, and I've been given that the perimeter is 32 inches. Well, students will need to know that when we're talking about perimeter, we're talking about the distance around the outside of the quadrilateral, and that we find perimeter with a formula like this: length plus length plus width, or 2 times length plus width. Both of those are formulas that you can use, and that will help you solve for a perimeter. So I'm going to take a look here, and thinking about my formula and adding all of the sides, one thing I like to do is also show the boys and girls that go ahead and fill in all 4 sides so you can see those measurements. We know that in a rectangle, opposite sides are equal. So if this side is 10, then the opposite side is 10. When I do determine my width, that will also be my width. They will be equivalent. So if I'm looking right now, and I know that I need to add all these up, I'm going to end up with 10 plus 10 plus W has to equal 32. Well, I know that 10 plus 10 is 20, plus W equals 32. So what we have to kind of think about is that I know that I have 20 out of the 32 inches around the outside. How much more do I need to get up to 32? That would be for both of those sides. Well, 20, how many more do I need to make 32? What would be that missing part? Well, I could subtract. I could say 32 minus 20, and I would find out that I need 12 more inches to make 32 all the way around. But I can't just put 12 here and 12 here. I have to share that 12 between my 2 sides. If I did 12 plus 12 plus 10 plus 10, my area would be bigger than 30. My perimeter would be bigger than 32. I have to share that remaining amount with my 2 W's. Well, one of the ways to do that is, since they're going to be equal, you're just going to divide it in half. 12 divided by 2 is 6. So I can fill that in up here. I think my width is 6 inches. And then I can kind of go back to my formula and check it. Well, if I have 20 plus 20, and now I'm going to fill this in like this, plus 6 does not make 32. 20 plus 12 is 32. So this dimensions on this rectangle should be a 10 by 6. It gives me a perimeter of 32. And I found that out by thinking about what I do have and what my total is that I need to come to. So this is kind of a fixed perimeter problem, we call it. Down here we're going to jump in, we're going to try fixed area problems. So that's kind of hard to read. That's feet right there. 9 feet. I know that I have 9 feet. I am missing my length. If that side is 9 feet, I know this side is 9 feet as well. This time I don't know the perimeter, I know the area. Well, my area formula is length times width. So if I kind of plug into that formula, I know the area is 81. 81 equals L times 9. Hopefully we know what missing number could go there. What times 9 would give me 81? Well, a lot of boys and girls will quickly figure out that 9 times 9 makes 81. Or you could also use your inverse operation. If you're missing a factor in multiplication, you divide. I could do 81 divided by 9. That would give me 9. So this, in fact, this quadrilateral is going to be a square with all sides equal. So with a fixed area, it really becomes a missing factor problem. All right. If I had said that the area was 72, it'd be the same. 72 equals length times 9. What times 9 makes 72? That would be 8. So here would be almost like thinking of this as your product and these as your factors. You're just finding the missing factor in area. That's our fixed area problem. Those are our fixed perimeter problems. They do take a little thinking through and a little bit of effort and computation, but most of us are being quite successful with those, and hopefully a little more practice. Everyone will feel really confident with that skill. Now we're going to jump over to the other thing that we worked on with area perimeter, and they did see a little bit of this in 3rd grade, I believe, is complex figures. So this is a complex figure because it is not a regular quadrilateral. It has more than 4 sides. It kind of looks like 2 quadrilaterals that have been kind of smushed together or conjoined. And that's a good way to think of it because that helps us solve it as we work on this. So when I'm looking at a problem like this, you're going to see sometimes that they have some lengths and measurements, but then they're missing. X and Y are unknown. So how am I going to figure out the length of X and Y? I need all my sides to solve for perimeter. I can't just add 10 plus 7 plus 4 plus 5 because then I don't have all the way around the shape. So I really need to find these missing sides first. To help you find what you don't know, use what you know. And use what you know that opposite sides in a rectangle are equal to each other. That will help you a lot. So if I'm looking at side Y, I'm going to think about what sides are opposite. It could be one side, it could be 2 sides in a shape like this. So if I look at the distance of Y, all the sides directly across from it, I'm going to swivel over them a little bit so you can kind of see. 5 and 7 are the sides that are opposite Y. I wouldn't choose X. X is next to Y. 10 is also adjacent or next to Y. And 4 is not really connected at all over here. That's not going to help me solve for Y. So thinking about that, whatever's over here, the distance from here to here would be the same as what Y should be. So to solve for Y, what I would want to do is I would add 7 plus 5. This line segment here has to be 12 because it has to be equal to the 2 sides opposite. Now for X, what are my opposite sides of X? So I'm going to go opposite, opposite. This whole 10 is the opposite side. So what is opposite 10? X, there's got to be another part because X is not the same as 10. Where's my other part opposite? It's that 4 right there. All right, so I can look here. X with 4 will be the same distance as 10. So I would have to add these 2 sides together to make 10. Well, 4 plus X equals 10. I don't know that, but I could figure out 4 plus what equals 10? That should be 6. I could say 10 minus 4 is 6. could use subtraction too. So now that you have all of your missing sides, you can find perimeter. Probably the trickiest part with complex figures and perimeter is just you're adding a bunch of numbers. In this case, we have 1, 2, 3, 4, 5, 6 sides to add, and there's more room to make a silly mistake. So you have to just be careful with your addition. Make sure you get all the sides. 7 plus 4 plus 5 plus 6 plus 12. Oh, that's not a plus. Plus 12 plus 10. I'm going to double check that I have 6 numbers. 1, 2, 3, 4, 5, 6. Yes. Double check, make sure you don't leave any sides out. And then what I like to do is you can go kind of straight through it and use some mental math, or you can kind of group numbers together that make tens and then cross them out as you go. So for example, I have a 10 to start, so I'm going to say 10. I know that 4 plus 6 makes 10, so I'm crossing them out as I add them up. So 10 plus 10 is 20. And then I'm going to add in my 12. 20 plus 12 is 32. Plus 5 more is 37. Plus 7 would be 44. So my perimeter should be 44 units. This one didn't have feet or inches. And I'm going to kind of just double check that real quick. If I go all the way around, 7 plus 4 is 11. Plus 5, 16, plus 6 is 22, plus 12 is 32, 34, plus 10 is 44 units. Always good to double check it a couple different ways. So my perimeter all the way around, if I wanted to buy a fence for this shaped yard, I would buy 44 yards, feet, whatever your unit is of fencing. Now, if someone said, hey, how much room does your dog have to run around in your backyard? I'm talking about area. Well, there is not a formula for a complex figure. But since we have a formula for a quadrilateral, what we're going to do is divide the complex figure into 2 quadrilaterals and find the area of each, and then add them up. I could divide this way with a horizontal line, or I could divide this way with a vertical line. I'm just gonna do that today. And then I kind of like to think of this is rectangle A, this is rectangle B, and let me solve for area. I have to be careful that I use sides that only belong to A. I need length times width. So I can use 7 belongs to A, and all of 10 belongs to A. I wouldn't use 4 because 4 is not all the way down the side of A. 4 is only this little part of A. So I need to use 2 sides that belong all the way down to rectangle A. So for area, 7 times 10 equals 70 square units. Now I need to do B. I'm going to be really careful. I see a 12. I can't do 12 times 6 because 12 is part of B, but it's also part of A. It doesn't just belong to B. What 2 sides belong just to B? 5 belongs to B and 6 belongs to B. 5 times 6 is 30. So this area is 70. This area is 30. The area of the whole complex figure would be adding those up. Kind of like partial products that we've done before. Is going to be 100 square units, or units squared. Just like that. So tonight, the boys and girls have some practice, and they have some problems that will look like this. And they are preparing for a quick little quiz that we will take tomorrow. So happy homeworking.